All right, so 3 methods of algebraic solving a quadratic inequality in one variable, x. Solve 2x squared minus 11x plus 5 is greater than 0 using roots and test points by completing the following steps. Right? So we're making a cake mix simple, right? That's what you got to do. Solve the corresponding equation. As a matter of fact, that's common to everything. You must solve the equation. So the equation is 2x squared minus 11x plus 5 is equal to 0. No matter what method we are doing, we must find the x-intercepts. So, hopefully it factors. And it does. And no, yeah, it does. And 2x squared minus 10 minus 1 is minus 11 plus 5. Okay? Every single time I factor, I check. I mean, if I don't, usually I get something wrong, but I get the signs wrong. You know, I put a positive when it should be a negative and vice versa. Okay? So, please, factor. The corresponding equation, x equals 1/2, x equals 5. You have to put the equals 0, right? You cannot just hang it out. Look, here's a factored something, expression. That's all it would be. Here's, if you wrote 2x minus 1 times x minus 5, it's an expression. It is nothing that can be solved. It's not equal to anything. How can you solve it? It's just an expression. Don't do that. Okay? You will lose half marks. It's sloppy work, right? It's like I'm rushing through this and I'm not really cognizant of what it is I'm trying to do. We are trying to solve an equation. It's got to be equal to something. It has to have solutions. We're solving it. We don't just factor it and say, God, I factored it, aren't I wonderful? No, we solve it, okay? You can verify this by graphing this. Don't do that while you're writing the test, okay? But you can come back later, graph that, and say, I expect to see 1.5 and 1/5, right? I don't need to get too fancy. A standard zoom on that, you'll just see something between 0 and 1 and something going through 5, and you'll say, yeah, it's probably right. If you see it going the other way, then it's like, oh, might have my signs wrong. Okay. Anyway, plot the roots on a number line. Okay, so we are going to draw a number line, and we are going to plot the roots. And the number line is going to sit kind of above this set of boxes. Okay, and I'm going to put the roots in strategic places. So this is not a scaled number line, but it does line up with the boxes below. And the idea is we have now split the number line into 3, count them, 3 intervals, right? We have numbers which are less than 1/2, we have numbers between 1/2 and 5, and we have numbers that are greater than 5. Okay? Why have we done that? I mean, if we sketch the quadratic, we would know that the quadratic, that's 1/2, that's what, you know, it looks something like this, right? And it has split it into 3 intervals, okay? So this is the analog, this is the graphical analog, right? But we're not doing graphs. And this stuff, this method sort of permeates this idea of the number line and the boxes, you'll see. Okay, so we have an interval. This interval is x is less than 1/2. This interval is x is between 1/2 and 5. And this interval is x is greater than 5. There are no equal signs on there because at 1/2 and 5, what's going on? You could say it. I give you permission to speak. At 1/2 and 5, when x is 1/2 or x is 5, y is equal to 0. Okay? So we don't need to test at that interval, right? We're not going to say, because it's not true at 1/2. If I said x is less than or equal to 1/2, it's not true. At 1/2 it's 0, but less than 1/2. Okay, so now we choose a test point that is less than 1/2. What's a good number that's less than 1/2? 0. Okay, so the test point will be 0. We substitute that into the equation. We say 2 times 0 squared minus 11 times 0 plus 5. And what does that give us? Gives us 5, right? Equals 5. Is 2x squared minus 11x plus 5 greater than 0 in this interval? Yes. So for any value of x that you put in that is less than a half, you will get a positive number, right? That corresponds to this graph. You can see it on the graph, right? But this is algebraic, which just says any value. And you could try, right? I mean, obviously, if you put a large negative number in, you're going to square it. Then you're subtracting 11 times a negative, so that's positive, that's positive, that's positive, that's positive. It's all positive, right? So it'll always be greater than 0. Okay, between 1/2 and 5, what's a good number to choose?
2.
Really? I'm going with 1. Well, you choose any number you want, but we have to substitute it in, right? And I find it easier to square a 1. So 2 times 1 squared minus 11 times 1 plus 5 is equal to, so we got 2, 7, negative 4. Okay. Now whether you chose 2 or 3 or, 4.716, just as long as that number was between 1/2 and 5, it's always going to, so the question is 2x squared minus 11x plus 5 greater than 0? No. So in this interval, any value you choose in this interval, and again, look, that's what the graph shows, right? Any value in here will be negative. X is greater than 5. Pick a number greater than 5.
6.
6, 10, yeah, it doesn't matter. Okay, just so you pick a number greater than 5, choose your own number. It may or may not be the same as somebody else's. Okay, doesn't really matter. Let's see, what number did I choose here? Oh, I choose 10. Just because 10 is kind of easy to square. So I got 100, no, 200, minus 100 is 9, I got 95 here. And what did it say? So you try your number, and people will have chosen different numbers. All right. Still, state the solution to the inequality. Based on the table above, when is 2x squared minus 11x plus 5 greater than 0?
X is less than 1/2.
Yeah. So we say it's a set of all x such that x is less than or equal, it's just strictly less than, because this is strictly greater than. So x has to be less than 1/2 or x is greater than 5. So there's our solution, right? And that matches up with the graph. If we had graphed this and drawn, right? But that's a graphical. This is non-graphical. Okay, so this is algebraic. So the idea is, and the idea for all of these really, it doesn't matter what method you're using, you must find the x-intercepts. Okay? And then you split the number line into an interval. So for these 3 methods, you split the number line into an interval. In this case, we pick a test point. Just choose a number that's in the interval. We work out, we substitute it in, and then we answer the question. Is that true? Is it greater than 0? Okay, any questions on roots and test points? All right, so the cake mix is laid out for you, right? State the corresponding, solve the corresponding equation. Equations are equal to something. Plot the points on a number line, not to scale, but just so intervals line up. Okay, blah blah blah. Solve. Negative x squared plus x plus 6 is less than 0 using sign analysis. Okay, so sign analysis is going to become a big thing. Bless you. Not that it's not a big thing already, it is a big thing, but all right, solve the corresponding equation. We actually have a couple of choices here, right? At this point we say, okay, so negative x squared plus x plus 6 is equal to 0. Now, if I were you, I would not want to factor something leading with a negative. Since it's equal to 0, I can multiply through by negative 1, and the roots are going to be the same. So this will be x squared minus x minus 6 is equal to 0. Now, you could say, well, you changed the equation. Okay, but I haven't changed the roots. So let's find the roots first. Then we'll sort of look at this graphically. So it's going to be x minus 3, x plus 2 is equal to 0. which says that x is equal to 3 and x is equal to negative 2, or x is equal to negative 2. Okay, so we have the roots. So if we kind of look at what we just did, we said the roots are at negative 2 and 3. The equation I solved is a parabola opening up. The original equation was a parabola opening down. So this is y equals negative x squared plus x plus 6. This is y equals x squared plus, minus x minus 6. What do they have in common? The same roots. Right? So when we're solving for roots, it doesn't matter if it opens up or it opens down. Okay. So I flip it because the problem is if you're going to factor with a negative leading x squared term, you're probably going to get it wrong. Because you need a negative x and a positive x, right? And something's going to go wrong with your factoring. So I prefer, give me a positive value of a. Always. Okay, I don't care. If I'm solving an equation, I want it to be a positive value of a. Since it's an equation, it's equal to 0. Since it's equal to 0, if I had negative 1/2, I can multiply everything by negative 2. Right? It changes the signs. Yes, you're plotting, if you plotted the quadratic function, it's different, but we're not doing functions, right? We are solving equations. Except now we're solving inequalities. So if I wanted this inequality, so let's say I did this, x squared minus x minus 6, what goes in between for the inequality?
Greater than.
Greater than. Okay, so that's less than. If I multiply by both sides by a negative, what do I do with the inequality? I flip it. So if we look at the purple, which is the quadratic equation, for the inequality, I want greater than, that's right? If we look at the red, less than 0, that's the same two intervals, right? So if you want to rewrite your inequality to have a positive x squared, be my guest. Okay? It's fine. All right? It's an identical inequality as long as you flip the inequality sign, having made everything negative, right? Changing everybody's sign. Plot the roots on a number line. So this time, here's the number line, and we have negative 2 and 3. Nice, 3. Negative 2 and 3. Now, the factors. So, I have a factor of x minus 3, and I have a factor of x plus 2. Now, those factors go with this, which means I want to solve this inequality. Okay? So, this is the inequality I am going to solve, because I don't like leading negatives. So I have changed it to this. You're allowed to, it's fine, right? As long as you do the same thing on both sides, stuff is cool. But if it's an inequality, when both sides are multiplied or divided by a negative, you have to flip the inequality sign. So my factors are, what are my factors? X minus 3 and x plus 2. And down here, we've got the whole thing. Okay, so if you're doing 31, you're going to see a lot of this. And now all we do, and to me this is easier than the roots and test points, right? You just say, if x is below negative 2, then what's x minus 3 going to be? Positive or negative? So if I've got a negative minus something, it's going to be a negative, right? So in this interval, the factor x minus 3 will be negative. Between 2 and 3, so just you take them like 0. 0 minus 3 is negative. If it's greater than 3, so something bigger than 3 minus 3 is positive. So what we're doing is a sign analysis on the factor by saying, all right, if I put negative 10 in there, I'm going to get negative 13, that's negative. If I put 0 in there, I'm going to get negative 3, that's negative. I'm still actually taking a test point, but if I put a 10 in there, 10 minus 3 is positive. Okay, makes sense? That factor, x minus 3, will be a negative if your numbers are here, negative here, positive. We do the same thing with x plus 2. So I take negative 1 million plus 2, that's negative. I take 0 plus 2, that's positive. I take 2 plus, or 5 plus 2, that's positive. Okay? So what we're looking at is we're saying I have these two factors. Now, when the two factors are multiplied together, if it's a positive times a positive, what do I get? Get a positive. If it's a negative times a negative, what do I get? If it's a negative times a positive, what do I get? Right? And that's the idea, right? So we're saying if I choose a number anywhere in the interval, so with x minus 3, if I choose a number between negative 2 and positive 3, so pick 0, I'm going to get a negative, right? X minus 3 will always be negative in those two intervals. And x plus 2 will always be positive in the far 2, right? Okay, so when I multiply, if I multiply negative times a negative, what do I get?
Positive.
If I multiply negative times a positive, what do I get? If I multiply positive times positive, what do I get? Right. Now remember, the inequality that I am solving is x squared minus x minus 6 is greater than 0. So I want to know, when is it greater than 0? What's the solution set? So what does x have to be? Positive when? X is less than. Now are we all strictly less than? Yeah, it's strictly less than, right? So x is less than negative 2, or x is greater than 3. Okay, so in calculus, we need to know this in intervals, right? We need to say, because stuff happens based on that, right? Various theorems that say, hey, if it's positive in this interval, then we know this. If it's negative in this interval, then we know this. And for us, it's just, now remember, we changed the inequality, right? Let's clean that up a bit. We can change the inequality as long as we do so properly, right? Okay, question? Sign analysis, very important. Last one, case analysis. Yeah, important, but still. And you get to choose one of these methods, right? So there will be one question on the exam that says solve this inequality algebraically. You got to choose roots and test points, sign analysis, or case analysis. Don't let me tell you. I don't want to influence you. Pick one that works for you. One of these you're going to look at. Like you might have just looked at sign analysis and gone, I'm not going to take Math 31, and so I don't need to ever learn that. Or you might say, I'm going to take Math 31, so let me work on that one until I understand it. But pick one you understand now, right? I mean, short term, you have to look out for your best interests. Eventually, you're going to have to figure out sign analysis, but that doesn't have to be today, this week, this month, this year, next year, first semester. It does have to be next year, second semester. But by then, maybe it just makes sense to you. It does. So you choose what works for you. Okay. Now, the only way you're going to know that is by trying a few things. So I think, I don't know if in the book they say use sign analysis, use case, but try each method, okay? And then eventually settle on one and just say, okay, if it's a test, this is the method I'm going to use because this is the one I understand. Okay, fair enough? Or leave it blank and I will thank you for not having to look at it. Stuff that. Anyway, solve. 3x squared is less than 7x minus 2 using case analysis. Okay, first thing, we cannot solve an inequality unless it is greater than 0, less than 0, blah, 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 right? Because we can't factor it. All right, so 3x squared, nice x squared, 3x squared minus 7x plus 2 is less than 0. Okay, so make one side of the inequality 0, the right side. It's always going to be the right side. And then factor the inequality. If this stuff doesn't factor, I mean, you can still do it, right? I mean, in those boxes, instead of negative 2 and 3, I might be writing 1 plus root 5 over 2. And in the other one, I might be writing 1 minus root 5 over 2. That makes it a little tougher to find, The idea holds. We're not going to pull that on you on a test. So if you're getting stuff if this stuff doesn't factor for you, you messed up, okay? This will factor. If we give you a quadratic inequality, it's going to factor. We're not going to throw at you some, radical that you got. what's the point? I'm not testing anything by doing that, right? Can I torture them to the point where, you know, they'll scream because now you're looking, well, in the interval below -1 minus √5/2. And you got to actually plug in numbers to see, you know, you got to put in your calculator and say, okay, it's below this decimal, and then I'll just pick like -100 or something. Anyways, in order for the, oh, we got to factor this, right? So what, -2 minus 1. 3x squared minus 6 minus 1 is -7 plus 2. You factor, you check. I don't care what method of factoring you use. So you can do guess and check, which implies you have to check. You can do over the rainbow, check it anyways. It's too easy to get the signs wrong, okay? And how long does it take to FOIL something out to check? Like seriously, 5 seconds, 10 seconds, if you're going really slow, right? Let's count. 3x squared minus 2x squared is 3 seconds. Okay, in order for the, so if this says that the product of these two things must be what? Less than 0. And what fancy word do we have for something that's less than 0?
Negative.
Negative. So they have to be negative. So if two things multiplied together are negative, then the signs of the factors must be opposite. Okay? You need one positive and you need one negative. In order for the inequality to be true, blah, blah, there are two different ways for the signs to be opposite. For each case, write a pair of inequalities and solve the system of inequalities. So, what can I say about 3x minus 1? We could say it's less than 0. If I have opposite signs, then what does that say about x minus 2? What must it be? Got to be greater than 0, right? That's how they have opposite signs. So I need to solve this system. They said system, it's not system in the sense. Okay, so we say 3x minus 1 is less than 0, 3x is less than 1, x is less than 1/3. So as long as x is less than 1/3, it's all going to be good. Oh, but wait a sec. At the same time, we know that x minus 2 has to be greater than 0, which means that x has to be greater than 2. So I need a number which is less than 1/3 and also greater than 2. There isn't one. This is not possible. Phone working okay? Battery charge?
Where?
Okay, this is what I need. That's my I need a number that does both of those. It's not possible, right? You cannot have it. Not possible. There is no number that satisfies this. Okay, case 2. So 3x minus 1 is what? Greater than 0, and x minus 2 is less than 0. Okay? What if this thing were, if it were greater than, so the inequality is it's less than 0. If it were greater than 0, then they would both be, or they would both be, right? They'd both be negative or they'd both be positive. And so your cases would be, they're both less than 0 or they're both greater than 0. Okay, so if it's less than 0, we have to have opposite signs, right? It's negative, you gotta have a positive, you gotta have a negative. If it's positive, they're both positive or they're both negative. Okay, solve this. So 3x minus 1 is greater than 0, 3x is greater than 1, x is greater than 1/3. Solve this. X minus 2 is less than 0, x is less than 2. Number line 1/3, 2. Okay, what am I looking for? What do I draw in the number line if I want to be greater than 1/3 and less than 2? I'm looking at this. And there is a solution to that, right? So I need a number which at the same time is greater than 1/3 and less than 2. Okay, I can do that. So what's the solution set? Solution set is that x is between 1/3 and 2. Okay, make sense? Let's go back to the dirty old way. So the dirty old way is this, right? All right, I know the x-intercepts are 1/3 and 2, right? 1/3, 2. I know this opens up, so I'm looking at a graph. One-third, 2. Okay, so graphically, this is what we're looking at, right? I have x-intercepts of 1/3 and 2. It opens up. I need it to be less than 0. That's this guy here. Okay, he's happy because he solved it.
It's pretty ugly.
Yeah, I know. It's not pretty, but you can't do it that way anyway. You can check it that way. You can solve it that way to begin with, yeah? You can just graph the thing, find the roots, graph it, say, I know what my answer is, but I'm not writing it down yet because I must justify it. And hey, I really like case analysis, right? Or I really like sign analysis, or I really like roots and test points. Okay, and I will show it. But I know, going in, I know what my answer is. It's kind of a low-cost thing, because it really doesn't take a lot to graph this. That's pretty low cost, yeah? You just sketch it out and put your factors down. Question?
If we have a question on the test, like you said, that would say use test points or
No.
sign analysis,
No.
would we have to like draw out the table?
No. You will not get a question that directs you to use. You will say algebraically, okay, solve, algebraically determine this inequality. Your choice is to use case analysis, sign analysis, root and test point. Your choice. We will not, on the test, subordinate clause modified, we will not direct you to use a specific method to solve an inequality. An equation, we will specifically, as we did yesterday, say, factor this. Solve by factoring. Solve by completing the square. Solve by using the quadratic formula. And then on the test, we will say, algebraically determine blah, in which case, your choice. I can factor it. I can use quadratic formula. I can use, don't use completing this. Please do not use completing the square unless specifically directed to do so, right? Especially on a multiple choice, because your answer is going to come out, remember the one we did? Your answer will come out in a different form than using the quadratic formula, which is the way the answers are going to come out that we're going to give you. And then you're going to have to translate it to that form, and completing the square is ugly, messy, time-consuming, and quadratic formula. Assuming you identify A, B, and C, and write down the actual formula, and then plug it in, it's you know, it's like shut your brain off for a while, right? You're just writing numbers and stuff. Just make sure that you reduce, okay? When you get root 40, it becomes 2 root 10. Oh, look, everything's even, I have to reduce that. All right, solve using case analysis. Again, what's with the case analysis? What's so special about it? Okay, so I'm going to rewrite it so that it's an inequality. I am going to rewrite it so that it's an equation. It opens up. I know it's the two branches, right? Like whatever this thing is. I don't know what the roots are. Okay, here, let's not put a... I know it does this, and I know that it's got to be greater than 0, so it's like this and this, right? I know the form of my answer right now, okay? It's like x is less than or equal to something, x is greater than or equal to something. And I need the some things. Okay, what do we got? 2x, x, 5 will give you 10, plus minus 3 equals 0. 2x squared plus 10. Yep, that works. Check. Okay, seriously, everything is wrong after this line if you don't check. Now, we're not going to deduct the marks as long as you're showing correct work. But, and here's the big but, if it goes wrong here, it often lends to you solving something that turns really ugly, which means you now spend 10 minutes doing something that should have taken you 2 minutes. Okay? So when you make a mistake early on, you can turn a nice, easy, simple question into a really ugly question you waste 10 minutes on, and then you don't get the last page, right? Like a guy on the 30-1 test said, I spent like 15 minutes trying to get this 2-mark question, and I ended up leaving a 3-mark question on the back, which I knew how to do. I left it blank. So, well, congratulations, you learned something, right? Like, honestly, you do the 2-mark question, you realize it's wrong, leave it. Go on, finish everything, come back to it later, you can look at it later. Don't go and sacrifice. What was he sacrificing? You already sacrificed for a half mark. Because you know what? He made one little mistake. So he got 1.5 out of 2. And then decided I got to fix that mistake. I'm going to spend 15 minutes fixing this mistake, giving up 3 marks. Doesn't make sense, right? Keep in mind, what's the goal? What's your goal on a test? What are you supposed to do? Do every question sequentially in order until it's solved correctly, 100% sure, and leave the back 3 pages blank? Is that your goal on a test? No, what are you supposed to do? Get the highest mark you can, right? How do you do that? Not by wasting a lot of time worrying and working over something that got you 1.5 out of 2. You want that extra half mark? Great. Come back later when you've got time. After you've finished everything else, you've checked stuff over. Then you can spend, all right, I'm spending 5 minutes now. If I don't solve it, it's not a huge deal. All right, anyways, in order for the inequality to be true, the signs of the factors. So this is actually greater than or equal to 0, so what do we know? The factors must be the same. Okay, solve it. Okay, so we have 2x minus 3. Let's do the positive to start. 2x minus 3 is greater than 0, and x plus 5 is greater than 0. So that means that 2x is greater than 3. I'm not going to rewrite the thing. I'm just going to remove the bracket. So x is greater than or equal to, right? Greater than or equal to 3 halves. And this is x is greater than or equal to negative 5. So if you're going to be greater than or equal to 3 halves, and at the same time greater than or equal to negative 5, then you're really just greater than or equal to 3 halves. Okay, so that's the one. That's the answer that comes out of case 1. If it has to be both of these, then it's the more restrictive. This is more restrictive, right? It doesn't allow the zeros or the negatives. Okay, so that's most restrictive. Case 2, 2x minus 3 is less than or equal to 0, x plus 5 less than or equal to 0. So 2x is less than or equal to 3, x is less than or equal to 3 halves, x is less than or equal to negative 5. That's the more restrictive one, right? Like less than or equal to 3 halves includes 0, but that's not really going to work with this. So it's got to be less than or equal to negative 5. So your solution is the set consisting of the x has to do less than or equal to first. Less than or equal to negative 5, or x is greater than or equal to 3 halves. And I know this solution comes as a shock, right? Because this is the negative 5, and this is the 3 halves. So we already knew going in that it was greater than or equal to 3 halves, or less than or equal to negative 5. And there we go. Okay, so that's that. And actually, I think when we do the absolute value function, we will have to do case analysis on that. So you actually do have to know these. I forgot. There's stuff coming up where you do have to know how to do case analysis on that, right?